If we go ahead and continue our talk about the elements, again, the first group of elements that you talked about were the metals. Now there are two more categories, and those are nonmetals and metalloids. To the right of the zigzag line, those are going to be your nonmetals. Nonmetals are located to the right of that zigzag line. Again, if you go ahead and look at the periodic table we said had that bold zigzag line. And that zigzag line was what was going to separate your element. Again, remember, to the left of that zigzag line was going to be your metals. Nonmetals, we said, were going to be located to the right of that zigzag line. So that's only these elements right over in here, kind of from carbon all the way over here to your 8 valence electron column. Simply put, nonmetals, they are not metals. Again, when you think of that prefix non just means not, opposite of. What we're saying is they basically have exactly the opposite characteristics of metals. They are very dull in color. They are not shiny, meaning that when we shine light on them, they're going to kind of have those earth tone colors. They're very brittle, and what I mean by brittle is when you start applying a force on them, they're going to break very easily. Remember metals, we said that they were ones that you could pound them into shapes, and we said that you could stretch them into long, thin wires. Non-metals, when you apply a force on them, they're going to break very easily. They do not conduct electricity at all. They do not conduct heat well at all. Basically what we're saying is they are not good conductors. But they are very good insulators, meaning that they are going to hold that energy well. So if you need to store heat, use a nonmetal. They have very low melting points, and they also have very low boiling points. And again, when you look at the periodic table, that is the reason why the majority of them are gases, because they have those low melting points and those low boiling points. Nonmetals, what they do is they form diatomic molecules. And diatomic molecules, what they are is they are two atoms of the same element that combine together to become stable. Now, there's only a few of them. So what you're going to have to do is you're going to have to memorize this list. There are 7 of them. They are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And what I mean by a diatomic molecule is this. For example, hydrogen. When it forms a diatomic molecule, it does it as H2. We breathe oxygen. Oxygen is going to be O2. So all of these are going to be 2 atoms of the same element that combine to become stable. Now let's go ahead and let's look at the periodic table, because I'm going to show you an easy mnemonic. Now again, there's an easy mnemonic to remember these. Now again, the one thing that you have to remember is there are 7 of them. So what I'm going to do is I'm going to say find element number 7. So what you do is you draw a 7. And when you draw a 7, you stop here at iodine. Now let's count them. Nitrogen is 1, oxygen is 2, fluorine is 3, chlorine is 4, bromine is 5, iodine is 6. And you might be saying, well, what about number 7? Well, what I want you doing is I want you looking at that I. And what I say is that I is a number 1. Here is your 7th diatomic, hydrogen. So let's go ahead and let's look at this one more time. When you go ahead and look at this one more time, as I said, draw a 7 at number 7. You're missing 1. Go to element number 1. These are your 7 diatomics: nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. Some family names associated with your nonmetals: group number 17, and that's your fluorine, chlorine, bromine, and iodine. They are going to be known as the halogens. Again, if you think of halogenated light bulbs, these are going to be some of the elements that you find in those light bulbs. Group number 18, we've talked about them a little bit already. We said these are the ones that are stable. These are the ones that have your 8 valence electrons. The noble gases, they are already stable and do not want to react with anything. The third and final category of elements is going to be metalloids. We have metals, we have nonmetals, and now we have metalloids. Metalloids, they are the ones that border the zigzag line. The only exceptions are aluminum and polonium, and these have all metal characteristics. If we go ahead and go to the periodic table, and again, when I look at this, when you think of that bold zigzag line that I talked about, and if I go ahead and I put that in here again, we said that the metalloids were going to be the ones that border. So here were the metals, here were the nonmetals to the right, and again, the metalloids are the ones that border. Boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. Polonium gets shifted to the metal side, aluminum gets shifted to the metal side. So again, one more time, metalloids border that zigzag line. Boron, silicon, germanium, arsenic, antimony, tellurium, and astatine. They do conduct a little bit of electricity, but they're not complete conductors of electricity. But the one thing that they are great at is they are excellent semiconductors, meaning that they can conduct, like I said, a little bit, but not all of the time. And that is the one thing that makes them extremely useful in computers. One of the main ones is going to be silicon, and silicon is going to be used in your semiconductors or in your computer chips.